Hello everyone and welcome back. My name is Mr. Koval, and in this video we're going to be going over the Big Bang Theory and where the elements have come from. Where did all these elements come from? Well, it starts from the beginning. But before we get into this, remember to like my videos, share my videos, hit that like button, make sure you subscribe to my channel, hit that notification bell so you could be notified by other videos I put out. So let's get into this. All right, so the question is, where did the elements come from? Well, it came from the Big Bang. The Big Bang Theory has multiple phases, depending on what phases or how it's divided up. Okay, so the first phase of the Big Bang occurs basically 1 second, so about a second after the actual bang, you have a boiling soup with electrons, and here quarks and other elementary particles as well. And the space cools off very rapidly, and quarks then come to form protons and neutrons. So this would be the first phase. Second phase, that would be where the universe becomes a super hot fog. So in this phase, heated protons, electrons, these are going to hinder the emission of light. So light's not really going to escape or pass through this. Light elements, this is where the lighter elements are created. So this would be like deuterium. Deuterium is hydrogen with a neutron. So it's double the mass of your normal hydrogen atom. And then you have lithium, helium. So these are the three lightest elements on the periodic table. And you could see that the first two phases correspond to the picture over here. So the first phase, this is about 1 second. You can see the temperature is like 10 to the 27 or something like that. Very, very hot. And and then 3 minutes later, 3 minutes after the Big Bang, you've got the second phase. This is where the lighter elements are created, and the temperature is somewhat cooler. The third phase, this is where your protons, electrons, and neutrons will finally combine to form atoms. So primarily hydrogen and helium atoms. This is the third phase here. This is 300,000 years after the Big Bang, and the universe has cooled to about 10,000 degrees Celsius. And then the fourth phase, this is where you get galaxy formation. Hydrogen and helium atoms are now going to form giant clouds, and these giant clouds are going to become galaxies and stars. So here we are out here. This is about 1 billion years after the Big Bang, and this is now the universe is about minus 200 degrees Celsius. And then the final phase, the fifth phase, dying, the first dying stars, they die, they go supernova, they're going to form the heavier elements, which is going to turn into new stars and planets. Our sun is about 4.6 billion years old. The solar system is 4.5 billion years old. And the Milky Way is about 13.2 billion years old. Okay, so that's the 5 phases. If we go to this next picture here, we see 7 kind of phases here. So again, you can see here in the first phase at time 10 to the negative 43 seconds after the Big Bang. And this is where the cosmos goes through, again, a super fast inflation, expanding from the size of an atom to the size of a grapefruit in just 10 to the negative 43 seconds. So really quickly. And then you have the post-inflation, right? So this is the next stage, according to this picture. This is where the universe is a seething hot soup of electrons. And again, this is where quarks and other particles are produced as well. This is at 10 to the negative 3 seconds. And so the temperature of the universe is 10 to the 27 degrees Celsius. Third stage is the rapidly cooling stage. So you rapidly cool the cosmos, and this permits quarks to clump into protons and neutrons. So you get proton to neutron formation here. And then the fourth stage, this is again 3 minutes after. You still have a hot mess here. So it's too hot to form atoms at this point because it's 10 to the 8 degrees Celsius. It's too hot, but charged electrons and protons are going to prevent light from shining. So we saw that earlier. So this is a super hot fog. So light isn't really going to escape through here. So this is like 3 minutes after the Big Bang. And here we have, after 300,000 years, the universe has cooled down to 10,000. This is where now the electrons combine with protons and neutrons to form atoms. So this is going to be mostly the lighter atoms, hydrogen, helium, those atoms. Okay, and here light can finally shine. So after 300,000 years, you'll be able to see light shining. 1 billion years after the Big Bang, now the universe is negative 200 degrees Celsius, and gravity makes hydrogen and helium gas coalesce or combine together to form giant clouds. And again, these clouds are going to become the galaxies and other stars, the first stars. And then finally, 15 billion years after the Big Bang, galaxies cluster together under gravity. Again, gravity is pulling things together. The first stars are going to die. They're going to spew out the heavier elements into space. And then these are going to be eventually the planets until you get to present day. And again, here's another picture of what's going on. So again, you have Big Bang, and then this was 13.7 billion years ago. And then 370,000 years after that, we get hydrogen and other molecules. And then stars are going to appear. This is going to be 100 million years later. So stars appear. And then you start to get nuclear fusion. Atoms are going to be coming together. So in blue and yellow stars, this is where hydrogen, helium come together. So hydrogen is going to form helium. So you're going to making heavier elements. In your red and red giant stars and blue white stars, you get a conversion of helium into these three larger atoms: nitrogen, carbon, oxygen. Plus, in the blue white stars, you also get these other elements forming. So these larger elements, carbon, nitrogen, oxygen, can combine together through fusion to form these other larger elements. And then in supernovas, you get the much heavier elements forming, like lead and gold and mercury. And so this is how these various elements came to be according to the Big Bang Theory. And so here's what we're looking at in the sun. So different elements are being formed at different parts of the sun. So you can see on the outer side of the sun, you have more of the hydrogen fusion occurring. So you have the lighter elements combining together to form larger elements. And then as you go deeper into the sun, you get the fusion of other heavier elements. You get helium fusion, carbon fusion, oxygen, neon, magnesium, and so on. So the farther you get in, the bigger the elements that are formed. And that makes sense because you have stronger gravity. So the stronger gravity is pulling these heavier elements together to create even heavier elements. And so you get supernovas. So out of the fuel, you get your elements, and then you get an implosion occurs, and you get supernova, and you form nebulas of elements. So here's an example on the bottom of a nebula of elements, and you can tell the different elements based on the color you see. And here's another picture of different nebulas. So these are I don't know if you've seen these before, these are very colorful pictures of nebulas, and these are elements that have been formed by supernovas and other things going on. And finally, here is a picture of the periodic table where it kind of lays out and colors the elements based on how they were formed and where they came from. So you could see that the top elements towards the top are going to be from Big Bang fusion. So right at the Big Bang, things are fusing together, cosmic ray fusion. So this is happening early on. So helium, hydrogen, and you get beryllium and boron being formed, lighter elements being formed from those first parts, first times, first uh, the beginning of the Big Bang. And then you have the more green elements, those exploding massive stars. So those are the heavier elements that are forming. And then you get the orange, which is merging neutron stars, huge stars, much heavier elements are being formed. And you got obviously a mixture of those as well. So you can get elements from exploding white dwarfs as well as exploding massive stars. So more than one event can create the same element. Okay, so that's it for this video. Thanks for joining me. I hope you enjoyed this video and you learned about how elements came to be according to the Big Bang Theory. If you enjoyed this video, please like, share, subscribe to my channel, hit that notification bell, and put a comment in the comment section. Let me know what you think and if you have any questions. Thanks for joining me. Have a great day.